So we can use the knowledge of the principle of SI unit dimension to get other units, which are the derived units. So we talk about derived units now. So derived units are actually obtained from the combination of two or more fundamental units, right? Are we there?
Yes, sir.
So these are some of the basic principles or formulas that if you want to look at some common formulas in physics and look at how we can get their dimensions and their derivation. I will ask you some questions though. I just want to do a quick review first from what we've done in the last class. For example, we can have area. What's the formula for area? Area of anything, maybe area of a rectangle or area of a square or whatever. Anybody? What's the formula for calculating area? I'm listening to you.
Half base times height.
The half base times height is most likely that of a rectangle, of a triangle, right?
Yes, sir.
Now, what is the area of a rectangle or a square?
Yeah, left side breadth.
Yeah, length times breadth. So that is of two dimensions. So we are talking about length and length. Length times breadth, right? Are we there?
Yes, sir.
Length is a dimension that has to do with a coverage of a distance. So whenever you are talking about the units, so the unit of length is m meters, and the unit of breadth too is also breadth is just like length too because it's a distance coverage, so that's also meters. So it implies that for area, the fundamental unit or the derived unit, I mean, of this area is going to be meter squared. Is that okay? Are we together?
Yes.
That is for the unit. And for the dimensions, we know the dimension of length is L. Dimension of another L length is L. So the total dimension will be L squared. So in terms of dimension of area, that would be what? L squared. Does that make sense?
Yes, sir. Yes.
Now, we can also have volume. Can anyone tell me the volume of the formula for calculating the volume generally? Anybody? Anybody?
Base times height.
Okay, let's assume you have a cuboid or something like this. This is just basic maths, right? So on your tool to calculate the volume of this, what's the formula to use? This is going to be base area multiplied by height. You got the point? So that would be area of base multiplied by what? Height. Are we listening? So the area, for
Yes, sir.
example, has two major dimensions. I mean, two major units. Here we have length here, and this could be maybe length or breadth. And here is the height. So sometimes we can say it is L times B times A. Are we together? Where the L and B for this kind of a question is representing the area. I hope I'm making sense.
Yes, sir.
So the dimension of L is of length, which is the length here. Let's begin with calculating the derived unit. So L there, that is the length which is representing meters. So that will be M. Am I communicating? Multiplied by the
Yes,
base,
sir.
that's also M. Multiplied by the height, that's also M. So it implies that the unit of volume is going to be M to the power of 3. Are we there?
Yes, sir.
And that is standing for the unit. Now, for estimating the dimension will be L multiplied by L multiplied by L, which will give us L to the power of 3. Right? This is the dimension of volume. Is that okay?
Yes, sir.
Now, we can also talk about some other forms of formula that are very common, like velocity. What is the formula for calculating the velocity of a body? Anybody?
Displacement over time.
Displacement over time. Thank you. Right? Or we can say change in displacement, right, over time. Now, displacement there is like the distance between 2 points. And displacement is very similar to what? Is it length, time, or mass? Who can tell me what is the appropriate unit for the appropriate fundamental unit here for displacement? Is it going to
Length.
be length, mass, or time?
Length.
Good, length. So if it is length, therefore the SI unit of length is m, that is in meters, right? Over time is in seconds. So this dimension will give me meters per second. The unit will be meters per second for velocity. Does that make sense?
Yes, sir.
Now,
Yes, sir.
velocity and speed have the same, unit. Speed is, what is going to be the formula of speed there? Distance over time, right? Because speed is a scalar quantity, while velocity is a vector quantity. So, but they have the same units, meters per second. Are we together? Hello?
Yes, sir.
Okay. Now, some other formulas, I'm going to do maybe like 2 or 3 more, then I will give you few ones to work with. Before I leave velocity and speed, let me take the dimension. For velocity, the dimension is going to be L over T, right? Which can also be written as L T to the power of -1. Do you agree?
Yes, sir.
Is anyone confused here? Madina,
Yes, sir.
do you understand?
Yes, sir.
Acceleration now. The formula for acceleration, anybody?
Velocity over time.
Yeah, that's what? Velocity over time. Or sometimes you say change in velocity over time. Okay? Now, we know what velocity is. in terms of its units, that is meters per second, right? Over the unit of time is seconds. So to get the SI unit of acceleration, that will be meter over seconds divided by what? Seconds over 1. And so this will give me meter over seconds divided by 1 over seconds. And this will be meter over second to the power of 2. So the unit will be meter per second squared. So that's going to be the unit of acceleration. Cleared? So the dimension of acceleration would be what? Now, from the unit we can detect the dimension. So that will be the dimension of m, which is meters, that's L, right? Then the dimension of time, seconds, which is time, is t squared. So this is the dimension of acceleration. Is that okay? Understood?
Yes, sir.
So I can use the units, the fundamental unit, to actually get the acceleration. Now, here is a quick question to everyone. Is Hussein in? I think Hussein is not here. I don't know why he's not there. Okay, 2 seconds. Now, force. I need you to get the units and the dimension of force. Force is 1. Number 2, pressure. You get the units and the dimension. Are you following? Number 3, you have impulse. Units and dimension. Now, start everybody. You have just 3 minutes to do this. Your time starts now. Hello?
Yes, sir.
Are you done?
Yes, sir.
Okay.
Yes, sir.
Now, what did you get for the first one? Anybody?
The unit
Newton.
of yes, sir.
The
Oh,
unit is
yeah.
Newton.
Okay. Who is going to give that one first? Who should I call? Olamide, what did you get as the unit of
Yes, sir.
force?
Newton.
Newton. But Newton is not a fundamental unit. What is the fundamental unit here?
Kilogram.
Is that what you got, or you are just saying it?
That's what I got.
Okay. Any other answer different from that? Any answer different from that? What did you get as your dimension?
M L raised to power minus from T raised to power minus 2.
Again?
M
Uh-huh.
L
Uh-huh.
raised to power minus 1
Uh-huh.
T raised to power minus 2.
Okay. Any other answer that is different from this? Please let's hear you out.
For pressure. Oh, force.
Migo?
Are you asking for pressure or force?
Okay, no, I'm talking about any other answer different from what you gave.
Yes.
Okay, now let's do the correction because of the time. Hussein, why did you come this late? Hussein, why did you come this late? Hussein,
So
come.
I was busy.
Uh,
I was busy.
no, you are busy. Now, what is the formula for force? Mass times what? Acceleration. Is that not
Sorry.
true?
Yes, sir.
Now, what is the unit of mass? Kilogram. Times, what is the unit of acceleration? Meter per second squared. Are we together? The SI unit of force is the same as kilogram meters per second squared, which is the same thing as Newton. But whenever you are told to estimate the SI unit, Newton is not the SI unit. The SI unit is kilogram meter per what? Second squared. Is that clear?
Yes, sir.
Yes, sir.
How do we get the dimension? From the unit, you can easily get the dimension. What kilogram is from what? Mass. So what is the dimension of mass? That is m. What is the dimension of m? M is about what? Length. And that is L. And T, S, that is time. And that is T squared. So this is going to be ml, right, over T squared, which is the same as ml T minus 2. This is the dimension of force. Is that understood?
Yes, sir.
Can you see that I didn't get it?
Yes, sir.
Is this one cleared now?
Yes, sir.
I'm talking to everybody.
Yes, sir.
Now, let's look at the dimension and the SI unit of pressure. What's the formula of pressure? Anyone?
Force over area.
God bless you. Force over area. What is the unit? What is the formula for force? You said force is mass.
Mass times acceleration.
Thank you. So, mass is in kilogram, right? Are we there?
Yes, sir.
Acceleration is in meter per second squared. I hope that's clear. Area is in what? Meter squared. I hope you are getting it. All these are the SI units. So pressure will be equal to kilogram meter, right, over second squared. Are you listening? Divided by area, which is m squared. Do you understand me?
Yes, sir.
So that gives me kilogram meter over s squared times 1 over meter squared. Cleared? This is equal to kilogram meters over s squared times 1 over meters times meters. This will cancel this. So you'll be left with kilogram over s squared meter, which is the same as kilogram per meter s squared. So that is SI unit for pressure. Does that make sense?
Yes, sir.
Now, this can also be regarded as Newton per meter squared, because force is in Newton, right? And area is in meter squared. So here is the SI unit. Is that okay? Is that okay?
Yes, sir.
So let's look at the
Yes,
dimension
sir.
from K, that's kg per meter s squared. So the dimension of kilogram is what? That is m, right? That's the mass. And meters is L, yt is t. Time is t squared. So that will give us m lt squared. Right?
Yes, sir.
So it can also be written, the dimension here can be, let me put it here, m, right? L minus 1 and t minus 2. So this is it. Understood?
Yes, sir.
The third one, impulse. So what's the formula for impulse? Anybody? What's the formula for impulse?
F times T.
Thank you. Force times time. So we've said force is mass times what? Acceleration, which is the same as kilogram per meter, right? Sorry, this is multiplication. That's kilogram meter per second squared. Are we together? Why the time is in seconds. So impulse, few seconds. Don't know. Okay. Yeah. Impulse would be equals to kilogram meter over second squared multiplied by second. So this one will give this, and then that will be kilogram meters per seconds. Cleared?
Cleared.
Okay. Now, with this logic, I believe you should be able to write the unit of several other derived units, either the unit or the dimension. So for example, the dimension of this would be kilogram, that is M, meters, that is L, and this is T. So this is going to be M, L, T minus 1. Okay? Now this, for example, can also be Newton seconds, because force can also be represented as Newton in terms of its unit, and time is seconds. So that is Newton seconds. Understood? Understood?
Yes, sir.
Yes, sir.
Okay. Now, please, this time around, what I'm going to give you, everybody must get it. You have to be dedicated. Just pay attention to this stuff. Because if you don't get this,
Okay, sir.
you might not be able to solve the questions you want to do now. So I want you to try as much as you can to be able to. If you need hints, let me know, please. Okay? Now, try the following. Get the SI unit and the dimension of the following. Density, right? Work done. And power. Please don't check AIO. Do it as much as you can. Start now. You have 2 minutes. Mute yourself, everybody, please.
Okay, good afternoon.
Mr. Lukman, Salaam alaikum, sir. Mr.
Wa
Lukman.
alaikum assalam wa rahmatullahi wa barakatuh. Ẹ jẹ́ má bínú, a ṣẹ̀ṣẹ̀ rí access sí kí
Oh,
ìtàkùn wọlé
Alhamdulillah.
ni o.
I've been engaging them
Yes, sir.
so far, and I
Yes, sir.
realize that their strength in dimension and SI unit is not well fortified yet. So
Okay. Yes.
I gave them this class exercise to do. So as soon as they are done, I will do
Yes.
the correction with them, and you can swing them, sir. Inshallah.
Okay, sir, no
You
problem,
can
sir.
just get set.
Inshallah. Okay. Let me launch my own this thing. Laptop.
You have less than 30 seconds, please. Are you done? Hello?
No, sir.
Where are you now?
No, sir.
Okay. You want me to give you more time?
Yes, sir.
Because your teacher is waiting already. Me, I just came in to stand in for a little while, so you will continue from there. Okay. Now let's quickly take the correction. Because there's no time again. Let me swing into doing the correction. Now, density. What's the formula for density? Anybody?
Mass over volume.
Density. Somebody was saying something. Speak louder now, Medina.
Mass over volume.
Mass over volume. Is that the formula for density, everybody?
Yes, sir. Mass over volume.
Now, mass over what? Volume. Now, let's get the SI units here. So, mass, the SI unit of mass is in kilogram, right? And volume is like you have length times length times length, or breadth, whatever. And so this is going to be in meter cube, right?
Yes, sir.
Meter. So density would therefore be equal to kilogram per meter cube. So that is what? SI unit. Now, the dimension. We know kilogram has a dimension of what? M, being a mass. While M has a dimension of what? L to the power of 3. So the dimension becomes M per L to the power of 3, which is the same thing as ML negative 3. So that's the dimension of density. Is that understood?
Yes, sir.
Work done. How many of you got this? Work done. What's the formula for work done? There are a number of formulas, but the one I want to use is
First time
First time.
distance.
MGA. You can use first time distance too. Which one do you want us to use?
First time
First
distance.
time.
Okay, no
Or first
problem.
time distance.
Let me use first time distance like you said. So that would be force times distance. So we know force is mass times what? Acceleration, right? then multiplied by what? Distance is in meters, right? Are we there?
Yes, sir.
So this is kilogram. This is meter per second squared. And this is in meters. So let's multiply all through together. That will be kilogram meters over second squared times meters. Are we together?
Yes,
So
sir.
this is going to give us kilogram meters per what? Meter squared, per second squared. So which can also be written as kilogram meter squared per second squared. Is that okay? And finally, what's going to be the dimension? Let me put that down here. So kilogram here, the dimension here is going to be m. This one, the dimension will be L squared. And this one, the dimension will be T minus 2. So here we have this. So that's the dimension. So in all, another way of representing work done, the whole of this is known as what? Joules. So I'm going to stop here for your teacher to continue. So we'll meet again in our own chemistry class. Assalamu alaikum. Bye for now.
Wa alaikum.